Hello, everybody. Can everybody hear me? Can you wave your arms if you can? Excellent, good. I can see some arms waving. My name's Glynn Bird. I work for IBM in the UK, and today's talk is called the Serverless Full Stack. I'll be creating a full stack application from a front end, middleware, database, everything, using serverless technology, showing you how to do that. If you've got any questions, go to slido.com and ask questions there, and we'll get to them at the end if I can, if you've got time. So first of all, some introductions. I'm a developer. I write code. That's my main job. I've been doing this for a long time. I write obscure symbols and words into text files, and I offer them to the computer and say, does this make any sense to you? And hopefully, the computer is going to do what I want it to do. But increasingly, as my career developed, I found myself doing a different sort of work. Instead of just handing over the code to somebody else, the sysadmin person who would run that code in production, I found myself being given this DevOps role of having to look after the infrastructure as well. So not only was I writing the code, I was having to configure the servers, the networking, the operating systems, the whole set of configuration and patches that requires. And I had to be up 24/7 to be able to manage it. I was responsible for the uptime of the whole operation, which isn't really my job. So this DevOps thing hasn't really delivered for me. The promise of the cloud has made my job slightly worse. I'm not doing the thing I liked anymore, which is dev. I'm doing more ops. So I'm pleading for being able to do more dev and less ops, like I used to in the old days. And hopefully, the serverless revolution will allow me to do that. We'll see as we go forward. So here's a brief history of the cloud, and hopefully you all are familiar with this. So back in the day, if you wanted a server, you'd have to go and buy it. You'd have to spend capital expenditure, and a server would arrive completely blank. You'd have to install your operating system, plug it in, rack it up, deal with the power and the networking and the heat extraction and all that sort of thing. And hopefully you ordered the right amount of servers, because if you didn't, then you're going to have to place an order, and 3 months later another server arrives. You get the idea. But then virtual servers came along, and we could rent a server from somebody else in somebody else's data center. So we're outsourcing a lot of that, and somebody else is picking up some of that slack for you. And containerization means that we can spin up servers in even smaller units of compute. Instead of having a whole server for 3 years in the physical world, or a virtual server running continuously ourselves, containers allow us to spin things up and spin them down really quickly. So the unit of computing that we can buy has dropped from a computer year to a computer second, effectively, a CPU second. And that shrinking of the amount of computing that we can buy opens up possibilities. In fact, it opens up the whole serverless revolution, in fact. The word serverless is a really poor name. Serverless doesn't mean there are no servers. Of course there are servers. They're just servers that you don't see. And this is a pretty familiar concept. We've dealt with serverless things for a long time. Databases as a service, platforms as a service have existed for a long time. We're quite happy with that notion that we don't manage the servers that the application runs on. We just consume it as a service. But this serverless word has taken off, so we have to run with it. I prefer a different term, which is functions as a service. So when people say serverless, what they really mean is functions as a service. And this is breaking your compute down to such a small degree that you've got individual functions running, not applications running 24/7, well, like a web server, for instance, but an individual function. And then you can have as many functions as you like, and you offer those to the cloud and say, you run these functions when I tell you. That's functions as a service. We'll see this in a bit more detail later, but it sits on top of the containerization we saw before. The key thing about functions as a service is that you don't have to predict how much work your application is going to need to do. You don't need to predict how many servers you're going to need. You just write the code that does the work, and it's the framework's job to be able to scale this up to any degree, from 0 to as much traffic as you can give it. And that's really important. The 0 is really important here. It means you've got no fixed costs. In the old days, you used to have to buy a server, and you would have a fixed capital cost that was yours. In this case, you put a function in the cloud. If nobody runs it, that's fine. You don't pay anything. You pay per CPU cycle that you consume. The unit of computing you're buying is truly pay-as-you-go, like a utility. It's like how much electricity you use, effectively. And this is a real advantage for developers who are trying things out. You don't have to succeed every time. It allows you to fail cheaply. And that's pretty important for developers. So we'll see how we create these functions, how we plumb work into them as we go along. But to do that, we're going to need an example. So imagine we come up with a brilliant idea, a new social network that we want to build, because the world needs another social network. In this case, it's going to be a social network with a twist. So it's got a familiar thing. You've got a login. You've got a username and password. So we need some sort of authentication piece where people register and be able to log in. And then when they log in, all they can do is upload photographs of dogs. This is the unique twist of my new social network. It's a dog-based Instagram, if you like. And we can like things, we can favorite things, we can share things, all the things you'd be expected to do on a social network. It's a website, looks like a mobile app. We haven't really decided how we're going to run this yet, but let's just go with it. And then my selling pitch here is that people can buy the pictures and pay $50 and get them delivered to their house. This is it. I'm going to go straight to the venture capital people and say, I've got a brilliant idea. They're going to give me £1 million, and I'm going to be rich. And we'll see if it's going to be a success. But how can we build this? What do we need? What tools do we need to build a website that's got storage, that's got that has to store images, that's got a login system, that's got a registration system, that's got the scalability? This could be a total failure and nobody visits the site, or it could be really successful and it needs to scale almost indefinitely. How can I engineer such a thing? Well, here are the components. You can see these 5 boxes at the bottom there. I need to be able to serve out static files. I'm a web developer, so I'm used to dealing with a web server. So I've got HTML, I've got CSS, I've got JavaScript. I need a web server to be able to serve that out to the internet. That's pretty straightforward. I need to be able to store files that people upload to me. So the pictures of the dogs, for instance. And they're pretty big, they're pretty hefty. I need to be able to store those securely. And most importantly, that storage must never run out. It's no good just having a fixed amount of storage, guessing how much storage I'm going to need. I don't know how much I'm going to need because I don't know how successful my app is going to be. Similarly, I'm going to need a database. So that's my unstructured data that's coming in the form of files. I've also got structured data. I've got users, I've got sales, I've got likes, I've got metadata of my images for a sort of search facility, for instance. I've got logs. And that sort of structured data needs to go into a database. Then the fourth piece is my application logic, the code that runs the site. What happens when somebody puts a username and password in that's incorrect? What should it do? What happens if somebody visits their homepage? What page should be rendered? This is my application logic. And finally, a session store. We're used to a session store. If you use PHP or any of the Node.js framework or something, the key is you log in, and if you get a successful login, you're given a cookie. That's stored on the browser, and that cookie gains you access to a session which stores a piece of metadata that represents the user. Session stores tend to be fast in-memory databases, for instance. So I want all of these 5 components. And the key thing is I don't want to have to manage servers. I'm a developer. So I want to run this in an environment where I don't manage any physical or virtual servers. Because even if I go for virtual servers, I'm still going to have to manage them. I'm still going to have to install operating systems and so on. So the old-fashioned way of doing this, if I was doing this five years ago, I would rent a server. I've got an idea. I'm not sure if it's going to work. I'll tell you what I'll do. I'll pick a cloud provider. I'll pay $10 a month, and I'll rent a server. It's only going to need 1 server, this application, and I'm going to throw everything on it. All the stuff that I need, all of those 5 components are all going to be on that 1 server. And that's OK, because it might work and it might not. And if it works, if I get loads of traffic, I'll scale it later. So I'm going to install a web server. Well, first thing, I'm going to install an operating system. Pick an operating system, configure it, install the packages I need. install my application stack, Java or Python or Node.js or PHP, whatever that is. Because people are going to be uploading files to me, I don't want to provision something else. I'm going to just upload it and put it on that hard disk of that machine. That'll do for the moment. And then I'm going to have a web server, something like Apache web server or Nginx, and a database, MySQL or Postgres. All of these things are free. They're free to download, so open source stuff, that's good. And I'm only paying £10 a month. I plug it into the internet, and off we go. I should be able to get something running, and it should only cost me $10 a month, and that's great. That's fine. And this is the way I would have done it 5 years ago. The trouble with that way is all of your eggs are in one basket. That one server has got everything. It's got all of the uploads. It's got all of the metadata. It's running your web service. If it is not up, your service is not up. So the downtime of your service is dependent on this one server. So how can we fix it? Well, if you read your How to Scale a Web Service handbook, it would say, well, break these things into pieces. You've got to have more than one of everything. So, OK, let's move the database onto another server. So we get another blank server, and we install another operating system, and we put the database on there, and we connect the two. That's more scalable, isn't it? Is it more scalable? Well, we've sort of doubled the capacity, if you like. We've doubled the amount of compute we're throwing at our system. We've doubled the price as well, by the way. The fixed cost has gone up. But we've also made it less reliable, because if either of these services are down, then our site is down. We haven't made it more reliable. And I've doubled the amount of headache. I've now got 2 servers I've got to manage, 2 sets of operating system patches I need to go through. This is painful. So you go back to your scaling your web app handbook, and it tells you you're going to need a load balancer. You're going to need to have different copies of these servers. So you buy a load balancer. That's another cost. Or you rent a load balancer, probably. And then you have 3 copies of your web server, because 2 isn't good enough. Because if you take one down, then you've got all your eggs in one basket again. You need at least 3 servers. So now we've got 3 servers, 3 sets of operating systems. We've got the storage at the bottom there. We've got a load balance. We've got to set the networking up so that it's secure. It's now a total headache. And I still don't know whether this thing is going to be a success or not. But I've now got 3 lots of $10 a month, plus a load balancer, plus whatever I need for this storage. This isn't a happy position. What I actually want is my 5 components that I had before. And I want to put a serverless stamp on each one. And my serverless stamp is saying, I don't want to have to SSH into any machines. I never want to install an operating system. I don't even care what operating system this thing is running on. I never want to patch a security upgrade. I don't want to be paged at 4 in the morning to tell me a server hard disk needs changing. I just want this to run, and I will consume it. If I use computing power, I'm prepared to pay for it. But I also don't want any fixed costs either. I'm pretty picky. So what can we use for these 5 pieces? If I can get all of these 5 pieces as serverless, then I've got a serverless full stack, OK? The first thing, the static file server. I can run my own web server. I know how to do that. But these days, I don't. I put my HTML, my CSS, and my JavaScript, and all of the other stuff I need to be able to run my website in a GitHub repository, and I tick a little box that says GitHub Pages. GitHub Pages then serves that website out on the internet for me for nothing, and I don't have to run anything. I don't have to run a web server. And the really handy thing about this is it's tied into my release cycle. Whenever I merge a change into the master branch of my GitHub repository, it goes live. I don't have to do anything. Really simple. They manage the content delivery network, the CDN, to spread that data around the globe in a much more efficient way than I could do. All that HTML, CSS, and JavaScript gets moved around the globe, and if my users are in Australia, they'll get a local copy of it on a server in Australia instead of doing a transatlantic hop. Because far away in a distributed system means slow, so you want it to be as fast as possible. All this happens magically with these services. Another one is called Netlify. I've never used it myself, but it's very similar. It's a paid-for service. They've got a free tier. But you point it to your GitHub repository and say, I want to serve my site out using this. Really simple. And you've got yourself a serverless web server. that you don't have to worry about servers. Don't log in, no operating systems, no nothing. You don't just have to host whole pages of HTML. You can break the HTML into a header and a navigation and a footer and a whatever, into pieces, modularize your code, and join it all together in Jekyll. Has anyone used Jekyll here? Some hands at the back. Jekyll is brilliant, really simple. It allows you to break your file into your pages into pieces and then assemble it then in the front end. And it turns your little pieces into a static website and serves it out for you. It's all built into GitHub Pages. It's well worth checking out. Another open source tool. How can we handle our uploaded files? Well, this isn't new news. This is old news. If you want an unlimited store of unstructured data that never runs out of space, that is almost always up, you want object storage. Object storage is probably 10 years old. I'm talking about Amazon S3. IBM, my employer, has a thing called cloud object storage, funnily enough. Every cloud has an object storage, and it's an unlimited place to put your files. Throw your files on there. This thing never goes down. I think S3 has an uptime of 99.99999 basically. This thing never goes down. You try building something with 99's reliability, you would struggle. And it's a pay-as-you-go service. There's no fixed costs. You pay for the amount of data you use. It's a total no-brainer. You want to store unstructured data, never run out of space, never goes down, object storage. Easy. You can also link it to a content delivery network. So if you want the data to come back out again to users, then you can plug it into a content delivery network, and that data will be distributed globally, and the people in Australia will get a copy of your data from a local server more quickly than they would. Same thing as the web server. So file storage, object storage, nice and easy. So that's 2 of our 5 things are serverless services. Now we get to the application logic. And this is where we start breaking our application into microservices. So instead of building one great big app, one big Node.js app or one big Java app, I'm going to break down my application into the smallest pieces I can think of. So I say, OK, what do I need for authentication? I'm going to need some sort of registration path, a bit like an API that I call, where they supply their username and their password that they want, and I decide whether they're a new user or an existing one. I want some email confirmation path. I want some sort of login method. I want a logout method. You might want a password. I forgot my password method if you want to go a bit further, that sort of thing. These are all my authentication things. I think about what I need to do, and I write the spec effectively for each of these tiny pieces. Similarly, for my picture hosting, I need an upload, I need a download, I need a share, I need a resize. Very straightforward. These are the things I need to do with pictures. So I'm building up a sort of hierarchical API, pic/upload, auth/login. And finally, my purchase path. This is where I might make my money. I'm going to use an external payment provider like PayPal or the other one. And I'm going to need a start point. I'm going to need an endpoint for the return from PayPal, for instance. I need people to be able to quit, that sort of thing. So these are my purchase-related endpoints. And by the time I've thought about it, I've got 10 or 15 endpoints that I want to build into my application. And these are my functions. So it should be no surprise to you, I'm going to pick functions as a service as a place to put my application logic. These are just individual functions that do very simple jobs. Does this username and password allow a user to get a session? A pretty small piece of logic, a couple of ifs and thens, a couple of reads and writes from the database. Not very complicated to write or think about or spec or test. So how can I host these services? I could host them in my own multi-server load balancer setup again, but this is the wrong way to do it. This isn't serverless. I'm responsible for the servers. I need functions as a service. In using a functions as a service, I only have to say, here's my function code. I want you to run this as Node.js 7.1 or Java, whatever it is, or Python 3.1, whatever it is. You tell it which runtime you want, and here's the code, and I will tell you when it needs to be run. That's it. In this case, I'm also giving it access to object storage, because this is my picture/resize endpoint. It's got one job: take a picture, store it to object storage. So it's got access to the object storage. It's really very straightforward. When you break your, it's a bit like when you break a monolithic system into microservices, but to the extreme. You've got the tiniest, smallest pieces that you could imagine. The market leader is AWS Lambda. AWS is the first one to market, and they are by far and away the biggest provider of functions as a service. They don't need me to promote their service. They're doing quite well as they are. There are others, though. There's not just one. If you read about serverless, you'd be fooled into thinking that there was only one provider. But in fact, every cloud has a functions as a service offering. Google, Microsoft, IBM. So if you're invested in a particular cloud, if your data's there, if the object storage that you picked is in a particular cloud, then you're probably going to want that cloud's functions as a service, because you want your data to be close to your logic. Because distance is time in a distributed system. So pick the cloud where your data is, or the one that you're experienced with. But it's not quite that simple. There are other functions as a service offerings that are related to event-driven things, like Twilio. Twilio do telephony, phone calls and text messages and things. So they've got a source of event-driven data, and they also allow you to attach functions, bits of logic that would run when those events happen. So it makes sense if you're doing a telephony application to pick them for that. Iron.io have a queue product. So you can attach code to a queue. So here's a queue of work, and then run this code whenever something goes in the queue. I'll just start throwing data into the queue, and they'll scale it out for you. So if you're invested in a particular platform, check out their functions as a service offerings. The big drawback of the main cloud-based ones is they are a closed shop. You can't run them on your own machine. You can't see the source code. You can't contribute to it particularly. With one exception, and that's Apache OpenWhisk. Apache OpenWhisk is an open source Apache incubating project. And it's got everything you need to run a functions as a service platform. You can run it on your own machine with a couple of lines. It'll run a Docker container with everything that it needs, all the dependencies, and you can just throw out your code. You probably don't want that for production, because then you've got to manage the server it runs on, and you're back at square one again. But it's quite good to be not locked into a single vendor's platform, if you can help it. If that's important to you, there's that. It just so happens, by a remarkable coincidence, that IBM Cloud runs Apache OpenWhisk as a service, so you don't have to run Apache OpenWhisk on your own machine. So that's good fortune. It's called IBM Cloud Functions. And just to give you an idea of how simple this stuff is, it sounds like it's going to be hard, this stuff, but it isn't, actually. So this is how you would create a very simple action, it's called, or a function, in a functions as a service platform. So Whisk, WSK, is the command line utility. It's got to be authenticated, but we'll forego that bit for a bit. So you're saying Whisk, action, create an action, a function, called hello, and here's my file, hello.js. And this uploads it, packages it, sends it to the cloud. Thank you very much. And it's then running in the cloud. Well, it's not running in the cloud, actually. It's ready to run in the cloud. And as soon as you want to invoke that action, it will run as many times as you like in the cloud, unattended, so you don't have to worry about it. That's really simple. It doesn't get much more complicated than that. I'll show you a couple of extra commands. If you want a bit more control, you can say, I want to model my hierarchy, my pick/resize, my auth/login structure in the naming. So you can have a hierarchy in the naming. So I'm saying, create an action called pick/resize. I want to specify a specific version of Node.js. So I want to say Node.js 6. It could be 7.1 or 8.3, whatever it is. And in this case, I'm giving it a zip file instead of a single file, because I might have some other libraries and bits and bobs that I need for it to be able to run. So in that case, I'm giving it, instead of a single JavaScript file, I'm giving it a zip file. And I should say, this isn't just JavaScript. This is it could be Python, could be Java, could be Swift, could be PHP. The platform can run all of these things. You just specify which runtime you need, and they will deal with it, which is pretty cool. You can have a mixture if you want. And finally, the last command line option I'll show you is this one, --web is true. And that really is saying, turn this function into a URL that I can call in the browser, or from curl, or make it into an API call, effectively. So if I run that command, here's my function, goes off into the cloud, and I get a URL back, which I can then invoke. I've effectively got something I can run attached to a webhook or to anything else that can make HTTP requests. There's usually a big old API gateway offering as well attached to these things that allows you to create a proper API. I want to post this, and I want to be able to put that, and specify the authentication and rate limiting and that sort of thing. But this is a really handy way of just getting up and going really, really quickly. And just to give you an idea of how, when I say function, people think, oh, it doesn't really mean a function. Well, I do really. This is a typical function. So this is a cloud function complete. I mean, it is using a JavaScript file that external here. You'll notice it's requiring an external file. But this file, if you can read JavaScript, which isn't the easiest thing to read, it's reading the current Bitcoin price from an API service. If it gets it correctly, it makes a database connection to an external database and inserts that data into the database. So effectively, it reads the Bitcoin price, puts it in the database, whenever you call it. So you create the function just to do that job, and then, well, when should I call it? Well, you can also attach time-based events to these things. So say, well, call this once a minute. And you've got yourself a cron in the cloud running automatically, filling a database with a current Bitcoin price every minute with sort of 6 lines of code. There's a couple of lines elsewhere that are making an HTTP request to another web service, but it's not very difficult. So your functions should really be small, easy to read, easy to understand, easy to test, with fixed known inputs, fixed known outputs, really simple code. So that's got us 3 of our 5 serverless actions. We're still missing the structured store. The 2 solutions I'm going to show you here are interchangeable. You could pick other ones. I've just picked one for the moment. So for a session store, I need something quick. I need something that, because every request is going to be hitting this store to say, is this cookie valid? Yes, on which user is it? And to do that, I need an in-memory database. Now, Redis is probably the market-leading in-memory database. You could pick Memcache, for instance, which is a similar job. Redis is a bit more advanced than Memcache. You can program it to do more things. In this case, I'm only using it to store time-limited keys, which are sessions, in other words. Because it's in memory, it trades speed for resilience. If you switch the power off, you might lose some data. But because it's in memory, it's really, really quick. As quick as it could be, as quick as a database could be, in fact. So that's exactly what you want for this purpose. It's open source, so you can run it on your own machine. You can run it in your own test environment, incur no fees. You can run it serverlessly by getting a cloud provider to run it as a service. Many cloud providers run Redis as a service. You just spin up a Redis instance, and it's there waiting for you at a certain URL. That will be a fixed cost because you're sitting with a VM running Redis. But at least you don't have to manage it. You'd never SSH into it. You never have to upgrade operating systems. It's all managed through a cloud platform. And for a database, I've picked CouchDB only because of the job I'm in. You could pick MySQL, Postgres, MongoDB, whatever you choose, really. But we're looking for a database that has a nice, simple API that can scale as my application scales. I picked CouchDB because it's schemaless in the sense that you can just throw JSON documents at it. So a JSON document describing a user, a JSON document describing the metadata for a picture. I don't have to define what that schema is before I write that piece of JSON. That makes it really quick for me to iterate and to get started, actually. That first commit is really quick. again, it's an open source project. There's a theme arriving here. Open source stuff is cool and free. If you can get somebody else to run it as a service, even better. Then you don't have to know it from the inside out. By a remarkable coincidence, Apache CouchDB is run as a service on the IBM cloud. It's called Cloudant, but it's effectively the same thing. It's got a nice HTTP API. Throw some JSON into it. Thank you very much. And you've got yourself a scalable database without worrying about the servers that back it up. So we've got ourselves a full stack application. It's got a front end powered by GitHub Pages. It's got file storage powered by object storage. It's got a database, Cloudant or CouchDB. We've got functions as a service doing the application logic. And we've got Redis doing the sessions. And I'm not managing any servers. And this thing can run without my unattended. And I can be a one-man band, a solo developer building applications. And this thing will run. To prove it, we need a live demo. So this is my GitHub Pages hosted website. So it's an entirely static website. There's no dynamic stuff going on here. And I can log into it. I mean, this is all dependent on conference Wi-Fi, which is particularly flaky today. So hopefully this will work. So when I click login here, that's sending an API request to a function, a cloud function, which is invoked. If I put the right username and password in, it will let me in. And it will then query the database and say, which is this user's most recent posts? And here's my most recent posts. I mean, who won't like this site? It's the cutest website ever. So that's making an API call to a remote service, which is calling to my database to say, get me the most recent pieces of metadata. And then I need the images. The images are on object storage, which is private. It's not public. So it calls another action to say, can I have access to this object just temporarily, just for a minute, because I need to render the image. So it gets a key back, and it calls object storage with that key. It gets some temporary credentials. So the data is actually, the data from the image is coming directly from object storage, but it's getting the key from a cloud function, from a serverless function. So I should be able to upload an image. Oh, drag and drop. I forgot about that. So let's try and drag and drop. I've got an image I prepared earlier. So I drag and drop an image, and this then goes and gets a key for the for object storage, saying I want to write an object, please. So I'm giving write access to my precious cloud object storage, but because I'm logged in, it's going to let me give me a temporary key. And the browser's speaking directly to my object storage. So there's no middleware at all here, other than the thing which is giving me the key in the first place. And I put my metadata here, and a description, and I click upload. And that calls another API call to upload the image, write something to the database, and then update my front end. So I've got what appears to be a dynamic website, but it's actually 3 HTML pages running off GitHub Pages. I've got a handful of serverless actions running in the middle, and I've got a database in the background storing the metadata, and I've got object storage storing the images. But I've got what appears to be a totally dynamic website. No infrastructure, no SSH, no operating systems. Awesome. So this is my serverless full stack. I hope I've completed on time, and I'll take your questions. I'll just wait for any questions to appear on the screen in front of me. If there aren't any, we can all go and have a quick break. I think it's all over. So anyway, thank you very much for listening. Enjoy the rest of your day. If you've got any questions, hang around at the end, and I'll answer them for you. OK, thank you very much.